Hello everyone, welcome to Mr. Schultz's Integrated 2 class. Today we're going to be discussing 2-5, rhombi, and squares. Please make sure your information is in the top left and right hand corners, and let's begin. So, a rhombus has 4 congruent sides. That's it. Now, it's also a parallelogram, but we'll get to that. So we have to follow the parallelogram properties. So opposite sides are congruent. Opposite sides are parallel. And then find opposite angles are congruent. And finally, the diagonals bisect each other, and they are congruent. Next up, square. We have 4 congruent sides and 4 congruent angles. So we have to follow the parallelogram, rectangles, and rhombi properties. So, example 1. Use the definition of a rhombus. So we understand that if LM is equal to 2x minus 9 and KN is equal to x plus 15, in rhombus KLMN, find the value of x. So we know that these two are congruent. So they have the same value. So we can say 2x minus 9 is equal to x plus 15. Now, we could use the definition of rhombus to say, hey, these two are congruent, and then say, hey, they're equal because of the definition of congruence, and then use substitution property to move them out. But we don't have to do that every single time. So we're going to subtract by x on both sides. Why? Because it says find x, and in order to find the value of x, we have to isolate for it. So I get x minus 9 is equal to 15. Now, instead of going, okay, what minus 9 equals 15, I'll just add 9 to both sides, and I get x is equal to 24. That's it. Let's go on. Example 2. Use the diagonals of rhombus. So they intersect at P. So if LMN is equal to 75 degrees, find KNP. So they want to know what's this equal to. So let's pause. So I know this KM is going to bisect the angle. So I know that, hey, if this is 75 degrees, then this is 75 degrees. But LKP, I could say PKN is equal to something. So I know that the measure of PKN would be half of LKN. And I know that, hey, LKN is congruent to LMN, which is 75 degrees. So I know that the measure of angle PKN is equal to half of 75 degrees. So this is what I have so far. I have PKN is 37.5. Well, I know what angle KNP is. So I'm going to put X because I don't know what it is. Now, the diagonals, when they bisect, they're going to make this perpendicular. So these are all perpendicular right here. So this is equal to 90 degrees. So now all I have to do is use the triangle angle sum theorem, which is these add up to 180, and just figure out what am I missing. 37.5 plus 90 plus x is equal to 180. Well, if I subtract it out, I get 37.5 plus x is equal to 90. Subtract it out again, And I get, using the subtraction property of equality, I get 60, 53, 52.5 degrees is equal to x. So angle KNP is equal to, or the measure of KNP is equal to 52.5 degrees. Let's go on. So example 3, use the definition of a square. So EFGH is a square. If FJ is equal to 19, find FH. All right, so I know that the diagonals bisect each other, so then JH is equal to 19. So 19 plus 19 would be FH is equal to FJ plus JH. Using the substitution property, I know, hey, that's equal to that. So then FH is equal to 38 degrees, or 38, just 38, not degrees, sorry. That's it. Let's go on. So I'm going to stop right now. Homework goes 1 through 19 on, but I want you to take off 11, 13, and 15. So we're going to take off a few of the examples. So you should only be doing page 95, numbers 1, 3, 5, 7, 9, 17, and 19. We're going to skip two of the examples. Now let's go to the last example. Now we're going to determine if this is a rhombus, rectangle, square, or none. Now, the first thing I would do is I'll be like, all right, how can I figure out what this is? So let's stop. The first thing I would be like, all right, are these parallel? So I know that the slope, let's say the slope of BC. The slope of BC, it goes up 1 over 1, 2, 3, 4. So it's 1/4. All right, what's the slope of AB? Well, let's say AD first. AD is equal to up 1, 1, 2, 3, 4. Hey, look, these are parallel. Okay, what about the slope of AB? Now, if it's going to be perpendicular, then it has to be the opposite reciprocal, so -4 over 1. So this goes up 1, 2, 3, 4 over 1. Nope, it's not negative, so it's not perpendicular. And 1, 2, 3, 4 over 1. So the slope, m of DC, or DCM, is equal to 4 over 1. So it's a parallelogram, but it's not a rectangle, and it's not a square, because it doesn't have right angles for our angles. There's something else. All right, so now what can we say? Okay, if it's a rhombus, now we could be like, all right, I'm going to informally, I know that these, I don't need to use the distance formula because using the slopes, I understand that they're going to be the congruent. Now, we're going to figure out, what about the diagonals? If the diagonal slopes are perpendicular, then this is a rhombus. So let's see. B to D, down 1, 2, 3 over 1, 2, 3. All right, so down 3 over 3. So BD, the slope of BD is equal to that. All right, what about AC? The slope of AC. Now this has to be 1 as well. This would have to be 1. Let's see. It's going to go up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. 5 over 5, that's equal to 1. These are perpendicular. So this is, the diagonals are perpendicular. So this is a rhombus. Let's go on. And that's it. So, guys, thank you for watching. I'll catch you guys in class. Hope you guys have a wonderful day. Bye.